To calculate the answer for each index, the shortcut is multiplying the entire array to get 24, then dividing by each index. But division is explicitly banned, forcing us to accumulate products from surrounding elements, building our results piece by piece. The brute force approach locks an outer pointer to the first index, sending an inner pointer to scan and multiply the rest. Moving the outer pointer forces the inner loop to completely restart, multiplying all over again while skipping the current position. Because the inner loop restarts for every single item in the array, the time complexity scales quadratically. This O of n squared approach creates an unmanageable amount of redundant calculations. While using constant space, quadratic time will trigger a time limit exceeded error on large inputs. To pass, we need an algorithm that runs in strictly linear O of n time. To reach linear time without division, we must isolate the components. For the number 3, we multiply everything to its left, the prefix, by everything to its right, the suffix. The prefix 2 multiplied by the suffix 4 gives 8. We calculate these values for every index by looping twice and storing the results in 2 new arrays, one for prefixes and one for suffixes. Once we have these arrays, we multiply them together, index by index, to generate our final answer array. We've achieved our O of n time goal, but allocating memory for 2 new arrays violates the problem's demand for O of 1 extra space. The challenge now is maintaining this logic without storing the prefixes and suffixes in separate arrays. The output array serves as a scratchpad for our running prefix values. Next, we calculate suffixes on the fly using a single variable looping backward. Starting at 1, we multiply the stored prefixes by the running suffix, updating it step by step to build the final result. By utilizing the output array as our scratchpad and tracking the right-side products with a single integer variable, we successfully process the data in linear time using constant extra space. Here is the visual cheat sheet for this algorithm. Feel free to pause and screenshot it for your notes. Finding the optimal approach often comes down to re-evaluating where you store intermediate data. Keep practicing, and I'll see you in the next problem.